This is video 4 for Class 2 of Umptium Calculus 3. In our previous videos, we worked a lot on graphing. We worked, and to produce the graphs, we said that, okay, we're going to set z is equal to a value, or a particular, or one of the other variables, set it equal to a particular value and see what the cross sections produce, right? And so we were initially graphing in the xy plane, and then in our last example with the saddle, we kind of switched to looking in the YZ plane or the XZ plane. Any of those strategies work. I just want to connect that idea of cross sections to this idea of level sets, and honestly, they're kind of the same, but there's an important difference that we will articulate. So the definition of a level set, we have to be given a scalar valued function. Okay, so this should be noted that this is a function, and the function needs to be a mapping from Rn to R. Okay, so we have to get one output, and we also need a real valued constant c. Then we say the set of all vectors x in that n-dimensional space, n-dimensional space, such that f of that vector x, so the function of that vector x, is equal to that constant c. That's a level set. Okay, so really we're taking the function of the vector x that we're given. Okay, so typically we're going to be working in 3 dimensions, so we just look at where that function is equal to a constant, where the constant is specified. And really, haven't we been doing this? Perhaps. Just some notes here on language more than anything. If we have n is equal to 2, then the level set is actually called a level curve. Okay, so what we get is a curve in 2D. And really what you can think of this as is if you think of a ball, and you take a rubber band around a certain part of a ball, and then you project that rubber band and its diameter, or its circumference really, and project it onto 2-dimensional space. That's going to be your level curve. Okay. However, using that same example, when we have that curve on the ball, that's actually going to be what we call a contour curve. It's a path around the it's a path that is the level curve, but it's in 3-dimensional space, not 2-dimensional space. Okay, so level curve, you take the rubber band and take it off the ball without moving, set it on a piece of paper, and that would be your curve. Contour curve, you leave the rubber band on the ball and just follow that rubber band around the ball. Okay. So we just want to do an example quickly, and we've actually done this example. We're just going to illustrate where this idea of level curves comes into play, or level sets. So we have this function, and we actually saw that this is the saddle function, and so we're just going to show one of these again. So we want to say, okay, well, to find the level curve, so the level curve that corresponds with c is equal to 0, okay, we're going to do that. 0 is equal to x squared minus y squared. Okay, and so this is fine. Okay, just this would also be the same as saying f of xy is equal to 0, which is then subsequently equal to that. But when we talk about the level curve, we would actually say it's the set of all xy, okay, so that's the vector x, right, such that x minus y, or x squared minus y squared, is equal to 0, okay, and really this isn't too different, but here's the catch, here's the distinction between cross sections and level sets. This is a particular cross section. This is a cross section for, let me write that again, for z is equal to 0. Okay, not x, not y. So when we're talking about the level sets, we're really just talking about the cross sections for z, not the cross sections for x or y. So the cross sections, the level sets are the cross sections that live in the xy plane for a defined value of c, or z, that is. Okay, and that's really all that there is for the distinction. Okay, so graphing isn't too different than we've already discussed. In the next video, we're going to see how to do this, perhaps with some technology to confirm our ideas. But in this video, it was really, we talked about level sets and curves being level sets in 2 dimensions, and we will actually be able to visualize the level sets, the contour curves, and the figures with the next bit of technology in the upcoming video.